Okay, I think it's about time. Greetings to all our guests. Welcome. My name is Can Karadoğan, and I'll be moderating today's session with my fellow colleagues from MIAM, home recording for performers. So before we go into the presentation, I would like to say we're open to all sorts of questions. You can also write your questions to the Zoom chat. I can conduct that, but we'll do the real Q&A session at the end of the presentation. So first we'll begin with the presentation. I'll give the floor to Laçin, Şahin, and Oğuz. Thank you for joining us.
Hello everyone. We'll first start with the video, and I think you'll have many questions after the video. So please write them, make notes while watching the video, and then afterwards we will answer your questions. Anything to add, Oğuz?
So if you are ready, I'm sharing my screen.
Hello everyone. In this video, we will explain some basic home recording techniques. Firstly, we will talk about the equipment. Secondly, we will prepare our recording space for home recording. Thirdly, we will record some acoustic guitars and vocals. And finally, we will do some editing and mixing. Let's start with the equipment that we are going to use. We will use a large diaphragm condenser microphone, a dynamic microphone, a stereo pair of small diaphragm condenser microphones, microphone clips, XLR cable, which is an audio cable, a pop filter, which we will explain further, a microphone stand, headphones, and finally, a sound interface. Before we delve into actual recording, it might be good to talk about the two types of microphones that we are going to use, the condenser microphone and the dynamic microphone. The basic difference between a condenser and a dynamic microphone is that condenser microphones are much more sensitive to sounds, which means that they tend to pick up more of the ambient sounds of the space that you're recording in. And that includes sounds from adjacent rooms and outside traffic noise as well. But they generally sound better than dynamic microphones in most circumstances. On the other hand, dynamic microphones are less sensitive to sounds, which makes them better suited to recording in a less than ideal recording environment. But they pick up sounds very locally, require the performer to stay very stationary, and are generally less suited for recording acoustic instruments. If you have an acoustically isolated room for recording, or have the means to improve on acoustically, which we will talk about next, the condenser microphone should be your first choice. Living rooms and bedrooms are not ideal recording environments. They are usually made of flat concrete walls and ceiling, and floor coverings, all reflective surfaces. Not good. But with some basic objects that you might already have, you can improve the acoustics of your room and make it more suitable for sound recording. Here, we see the corner of the room that we are going to record in. As you can see, there is no acoustic treatment at the moment. Here is a sound clip from the room when I clap my hands. First, the microphone sound. Please listen to the echo of the room in both recordings. Second time with the video camera sound, which is actually a mobile phone. After this recording, we gather some extra carpets, put them on the floor and the wall behind. In addition, we put thick curtains on the window and on the wall on the right side. Now listen to the new sound clips after our simple acoustic treatments. First, the microphone sound. Second time with the video camera sound. As you can see, there is a fair bit of improvement, which is going to translate well into our recordings. During the recording, the microphone has to stay stationary and should be pointed towards the sound source that you are going to record. To do that, we have to place our microphone in a microphone clip and mount the microphone clip on a microphone stand. The microphone stand has an adjustable body and an arm which you can utilize for the positioning of the microphone. If the body of the microphone stand is touching the floor, it can transfer extra noise to the microphone, so take care to avoid that. XLR cables are industry standard cables for most microphones, which we plug into the microphone and the input of our sound interface. A sound interface is a unit that is made up of three main parts: audio inputs, audio outputs, and computer connection. We connect the sound interface to our computer through a USB port with a USB cable. Before doing that, however, you must install your sound interface's latest driver. From the driver menu, you will have to adjust your buffer size for around 256 samples or less for accurate monitoring of your performance. If you adjust it above 1024, you will hear a latency between your acoustic sound and your recorded sound, which will hinder your performance. So we suggest keeping it around 256 samples or less. To record your performances, you will need sound recording software, which is usually called a digital audio workstation. For this tutorial, we will use a program called Reaper. When you open the Reaper program, you will have to set your audio interface or its driver as your sound interface and adjust correct input and output settings. Double-clicking on this area will create a new mono audio track, which we will use to record our performance into. Now we can connect our XLR cable to one of our sound interface's available inputs. To work properly, condenser microphones generally require 48 volts of electrical energy. This energy is called phantom power, and it can be sent from your sound interface through the XLR cable by turning on its designated switch. Now we will have to adjust our microphone signal level, which is called gain. It can be adjusted by turning the knob next to our audio input. The best way to adjust proper gain is to play the loudest parts of your performance and see the peak indicator turn red. Then turn the gain knob until the peak indicator disappears. This way, you will get the healthiest signal level from your microphone. Now you can connect your headphones to the headphones output. In the digital audio workstation, click the red button on the audio track to hear yourself. You can adjust the headphones level from its designated volume knob. Try to keep it as minimum as possible to avoid leakage from the headphones to the microphone. The record button on the audio track does not initiate the recording. To do that, you need to hit the master record button. Now you can record yourself. In our first recording example, we will record an acoustic guitar with a condenser microphone. You can think of the acoustic guitar as any lute type instrument such as oud, banjo, bağlama, or bouzouki. Condenser microphones can sense sound from any direction, and directions are called polar patterns. Condenser microphones can switch between different patterns or can be manufactured as having just one pattern. For example, a cardioid pattern. When in a cardioid pattern, the condenser microphone becomes sensitive to sounds coming directly in front of it and ignores the sounds coming from the back and its sides in substantial amount. We usually use this pattern to focus the microphone to its front. There are other patterns as well, such as omnidirectional, which makes the microphone sensitive to sounds coming from any direction and makes the sound more natural, but this pattern requires a very isolated recording environment. The polar pattern that we are going to use in our examples will be the cardioid pattern, which will make the microphone more sensitive to sounds from its front and less sensitive to sounds coming from its sides and its back. When miking any instrument, the general idea is to avoid positioning the microphone directly in front of its sound hole, even though it might be the first thing that comes to mind. When positioned in front of the sound hole, the microphone hears the bass frequencies more, which might be called a muddy sound in the sound engineering world. To get a balanced sound, we usually aim a little bit away from the sound hole, which tends to be around the 12th fret, or the part where the neck joins with the body on lute type instruments. Here is the sound from the 12th fret position. Now, let's hear the sound in front of the sound hole. Try to notice the difference in the timbre. Another miking technique is to position the microphone facing the bridge. Now let's switch to our dynamic microphone. An important thing here to note is that dynamic microphones do not require phantom power to operate. So you must switch the phantom power off before connecting your dynamic microphone. Let's hear the dynamic microphone from the same three positions. When recording in stereo, one of the microphones usually faces the left side of the source, and the other microphone will face the right side of the source. The time difference and level difference between these two microphones will create the stereo panorama. The stereo miking technique that we are going to use in our recording is the XY stereo miking technique. In XY stereo, two cardioid microphones are placed coincidentally, almost touching each other at a 90-degree angle between them. The diaphragms of the cardioid microphones will face the source. For other stereo miking techniques, please refer to the links that we will provide you. When recording vocals, it is best to stay in a range of 10 to 20 centimeters away directly in front of the microphone. When in cardioid mode, microphones tend to exaggerate the bass frequencies in the recorded sound when you get closer to the microphone. This effect is called proximity effect. When you get closer to the microphone, you will hear an increase in the bass frequencies. And when I move away from the microphone, you will hear the bass frequencies less and you will hear a more balanced sound. So when you are recording vocals, this distance, like 15 centimeters away, will give you a balanced sound. If you want to use the proximity effect to increase the bass frequencies in the recorded sound, you can get closer. And if it's not adding anything good to your sound, you can move a little bit away from the microphone. If you think that you have a voice that can benefit from this effect, make sure to get closer to the microphone. Another important thing when recording vocals is to use a pop filter. Without a pop filter, plosives become exaggerated. And with a pop filter, they sound more natural. Let's listen to some clips with and without a pop filter. Without pop filter, the plosives pop out. The pop filter makes the plosive disappear. Without pop filter, the plosives pop out. The pop filter makes the plosives disappear. Now, let's hear a vocal recording example with a condenser microphone. December snow falls into my heart. December snow falls into my heart. The most basic type of editing is cutting out unnecessary parts of a sound recording. For example, you might want to delete the section from the start of the recording to the point where the actual performance starts. To avoid a sudden start of the performance, it would be good to add a fade-in. Same principle with the ending. To avoid abrupt sound level changes, you might leave the recording until the sound of the instrument decays completely and then add a fade-out. Another thing you can do in editing is replacing bad parts of one performance with good parts of another performance. We were generally satisfied with the second take of the vocal recording, but we weren't satisfied with the first line where I say December. Let's give it a listen. December snow falls into my heart. This line is okay in the first take. December snow falls into my... So what we can do is replace this bad portion with the good portion from the first take. To do that, we select the section from the first take, copy it, and then paste it on top of the second take. To create a smooth transition from one take to another, we add a crossfade in between. Let's give it a listen. December snow falls into my heart. There are more advanced sound editing techniques, but we might talk about those in another video. Mixing is basically a sound level adjustment. If there is only one instrument, then we adjust the sound level of different frequencies that this instrument produces. We call this equalization. In short, EQ. When we apply equalization, we adjust the balance between high frequency, mid frequency, and low frequency contents. We might make a dull recording sound more balanced by boosting the high frequencies. December snow falls into my heart. Or we might increase the low frequencies of a recording and make it sound more wholesome. December snow falls into my heart. We can also decrease certain frequencies. For example, we can cut some mid frequencies in nasal sounding performance and make it sound more natural. As we have said before, mixing is volume adjustment. If we have two instruments, or in our case, for example, an instrument and a vocal, we can balance the level of these two tracks. Let's align the two performances first. And let's give it a listen without any volume adjustment. December snow falls into my heart. December snow falls into my heart. As you can see, the vocal suppresses the acoustic guitar. What we can do here is decrease the volume of the vocal track or increase the volume of the acoustic guitar track. It really depends on how much headroom you have before you see red peaks on your master channel. December snow falls into my heart. December snow falls into my heart. December snow falls into my heart. Your master channel is the final output where every track in your project flows into. To have an undistorted final mix, you should not see any peaks in your master channel fader. Another mixing tool is the compressor. Compressor balances the dynamics of a recording. After a compression is applied, the sound level of loud and soft portions of a performance become closer to each other. Application of a compression requires more detailed instructions, so we will leave it there. Time-based processors, such as reverbs, could also be added into the mix to make a dry recording sound more natural. Using a little bit of reverb can add ambience to your recordings, and it will also help combining different tracks into one stereo mix. December snow falls into my heart. 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 Unless you want to sound like you are in a Turkish bath, keep it at moderate levels. For further details about using reverb, delay, and other time-based effects, please refer to the links that we will provide you at the end of this video. Mastering is the final stage where we combine all our tracks together into one, and if necessary, apply equalization and compression to their unified whole. There are many elements that we can check and apply in mastering, but adding a limiter is the most crucial one. Limiter is like a more powerful compressor. It increases the overall volume while letting you set a certain level where nothing can exceed. This level is called the ceiling, and we usually set the ceiling to a safe level of -1 dBFS. This setting makes it certain that our recording does not go above 0 dBFS, where distortion starts and we hear audible noise in our recording. December snow falls into my heart. December snow falls into my heart. Other limiter plugins might use other types of settings, so you should check them out. Bouncing or rendering is the process where we combine our tracks into one stereo audio file after every other process is completed. In order to do that, we select the time period that we want to combine into one. Then we go into the bounce render preferences. Here we select the type of our bounced audio file. We have to select 24 bits and 44.1 kHz wave file format. This setting is an industry standard for most audio projects, and will guarantee that your final bounce file is uncompressed and lossless. We hit render to bounce our mixed project. And finally, always make sure to give it a listen before you send it to someone else. In this video, we tried to cover the basics of home recording. As you might guess, there are many other things that we can talk about. But we hope that this video will help you get started with making your own recordings at home. Make sure to read more about the subjects that we have covered, and always keep experimenting. Thank you.
We thank you both for this great presentation. It's a hard job to put all these audio information together and combine a beautiful video out of it. I believe it aroused many questions in our participants' minds, so feel free to write in the chat, or maybe you can directly ask and turn on your microphone. If nobody has any questions, I'll dig in, but I'm waiting now.
Maybe hocam, first we should share the further read books.
Yeah, I have the PDF. I can do it if you want to.
Let me try.
Or you can do it. Oğuz will share the major books that we mostly refer to in our sound engineering and design education, where Oğuz and Laçin both are instructors and appliers in the studio too. So we only decided on the books that focus on recording and mixing, not into other processes, of course. Did you share it?
I cannot share the PDF on chat.
Let me see if I can do this. There you go. I have it on the chat. We gave the Amazon links for those books, so you can find out the authors and, of course, locally order them. So, any questions? You can raise your Zoom hand as well. I have a question regarding actually European standards for sound environment in apartments. Can you do recording or in a normal flat in any country in Europe, or you have to keep some levels?
Or we can just ask, did you do any home recording before?
Basma has a question here. Are the softwares free? Perfect question. No, they are not. But Reaper is. Laçin, why am I digging in? I'm just a talkative person.
No,
Please,
you can just
Laçin
tell
or
hocam,
Oğuz,
you can tell.
just you have the floor. I'm just a moderator. Laçin.
Reaper is not free, but you can use it. I mean, how
But
can I
it's their
say it?
policy, yes.
Yeah.
They allow you to use it
Yeah,
forever, actually. But they always give you the warning and keep you waiting for 5 seconds. That's the penalty they give you without paying. So they're reasonably understandable. And a very good software, by the way.
It actually has all the tools in it. I mean, the compressor, EQ, limiter, the things that we've talked about.
That is also an important thing. Normally, you have to combine plugins with the digital audio workstation. So you have to buy 2 or more groups of software. Reaper has this one and all thing. And it's very adaptive too. Is there anyone in the audience that are doing home recordings?
Actually, may I ask about the microphones? Actually, so I would like to start recording at home, but I don't have any microphones at the moment. What do you recommend for me?
Good question, indeed.
And how much? Prices, I mean.
The microphone that we used in the video, large diaphragm condenser microphone, is Rode NT1A. I'm just checking the prices now. It says 155 euros. And we also use an SM57 dynamic microphone. I'm not sure about the price, but it's usually around 100 euros or $100, I guess.
Yeah, something like this. And also we were using MXR pairs. They are maybe a bit expensive than others. But all the microphones are not that expensive microphones. It is the actual thing that we wanted to show. With that cheap microphones, you can even get the sound with at your home.
So that I can start with buying, for example, I'm a cellist. So do you recommend for me to buy which one of the microphones, like the cardio?
I think we cannot go into advertisement here, hocam. But
not as a brand, but the type, I mean.
Actually, small diaphragm condenser mics are good for home for most of the usage. And also you need to get sound card for the connection with computer. And this sound card is also is discontinued product right now, but is also not that expensive one.
Okay, thank you very much.
And also there are some starter packs that you can buy. Headphone, sound interface, and also microphone, cables, all in one. I'm not sure how much they cost, but they can get you started.
Basma just asked me about the big difference between brands of microphones. Yes, there are, of course, but maybe Laçin or Oğuz can give more details. What makes a microphone more expensive than another one, and why do they coexist in the market?
Laçin hocam?
Well, I mean, until a certain price point, you get increasingly more performance out of a microphone, and after some price point, you get less for the more you pay. I mean, let's say that you have a $1,000 microphone and a $3,000 microphone. Maybe you won't hear the difference between them. You have to really do lots of testing and experimenting. But under like, I don't know, maybe $1,000, you will get more for the price that you pay. What's the difference? I mean, if it's a multi-pattern microphone, it will cost more. If it's, I mean, usually if it's a large diaphragm condenser microphone, it will cost more. And also, some microphones have really certain characteristics, like that are good for certain applications. And some of the microphones are fairly neutral. If they have these good qualities, they cost more. And usually dynamic microphones that we use, like the SM57, they have been in the market for a very long time, and actually we got used to their sound. So I guess that's why they cost around $100 or €100 and not much more. I mean, that's all I can say. Yes.
And the big differences between the expensive and cheap microphones is actually the noise ratio of them. And that's why if you pay more for a microphone without a good acoustically treated well room, actually there is no big differences because the room is not sounding good. So if you are just a home producer, or if you just want to start that home recording stuff, the first thing that you need to do is the acoustic treatment, not just isolation, also the room's reflective surfaces and other things. Even in the video, you can see that just the one carpet on the wall just changed everything in the room. This is the actually most important thing that you have to be care about. And also the other thing, the microphone placement is more important than the microphone itself. Even in the video with the same microphone, in the different placement, the sound is drastically changed. While you are recording it at home, even with the other instruments, just try.
Apropos that, Oğuz, Martino has a question on the chat. He says, hi guys, how about recording a duo or a trio in a bedroom with just one microphone? Any suggestions about the disposition of musicians or microphone?
You can use an omnidirectional microphone. But actually you talked about it in the video. It will capture the sounds from front, back, and sides. So if you position the trio or duo around the microphone, you will hear all of the musicians. I mean, if you use a cardioid microphone, you have to focus them on the front of the microphone, and that might cause some masking actually. So you can use an omnidirectional microphone, but be careful about it because omnidirectional microphone is going to pick up lots of ambience. So you have to treat the room more important. Yeah.
And also your acoustic balance will be much more important than microphone. And also I think you should use omnidirectional microphone because with the cardioid microphones, while you are getting further away from the instrument, the low frequencies are getting weaker and weaker. With the omnidirectional microphones, just because they don't have that proximity effect, the sound will be much more balanced.
Yeah, and since you play double bass, you should use an omnidirectional.
Apropos that, I think we need to add also that instruments with bass content, such as double bass, cello, or drums, might trigger the room modes more than other instruments. So then your good microphone will capture all the artifacts of the room more than the other instruments. But if you have a small fiddle like a kemençe or maybe even a guitar, could not cause that many problems. Therefore, you have to listen to it in the room first.
All in the books that we just shared in the chat, in these books you can see all the details actually, how to use microphones in other instruments. what should be considered while you are miking something.
Another question from Davide. Hi, I have two questions. I want to record a drum. Which microphone should I use, and can you recommend me a free app to record? Laçin? Oğuz?
Actually,
Or
recording drums with one microphone is like a very favorite YouTube challenge.
Don't forget the Beatles did that. Don't
yeah.
forget.
I think I mean, you can do it with one microphone. Again, a normal directional microphone would be good. I think it's around somewhere between over the kick drum, looking at the snare kind of placement, I guess. That can work. But if you can afford to buy two microphones, that would be better. Like two cardioid microphones, maybe. Or again, two omnidirectional microphones to get the stereo image of the drum. Free app, I mean, Reaper. You can use Reaper. It's not free, but you can use it.
You can evaluate it.
You can evaluate it for
forever.
For a lifetime, forever.
By the way, there's of course a competition between these softwares, these digital audio workstations, and we in the professional studio in our university, we use Pro Tools, so we tend to have all our students to learn that. We really slap them to learn it, because they cannot exist in the market without Pro Tools knowledge as an engineer. And people pass on from project to project over Pro Tools. Once we had a session from France, I remember Oğuz did the recording with I forgot the artist names, I'm sorry. The Pro Tools session came, the recordings were done in Pro Tools, and then they did continue that back in France like this.
René Garcia Fons, the
Yeah.
bass player.
And if you have Macintosh, people tend to use Logic Pro very often. And if you're into Dolby Atmos, you need to learn either of them. That is the latest new thing, by the way. Any other questions? Well, then I guess it's time to thank our presenters, Laçin and Oğuz. Great work. Congratulations. And thanks to Medinea On Air and MIAM.
Thank you for watching.
And should we announce the next session also, Basma?